Ready in just about a minute. Good morning. So YouTube is doing this thing which is kind of annoying. It keeps saying that I only have one viewer, but there's been 2 comments so far, and I do not believe that I have only one viewer. And I'll show you. I'm not making this up. So here's my computer screen. This is what it looks like. See, one viewer, and that's it. Yeah, and now you can see how delayed the video is. Look how long it takes for the video to be delayed. See? It's like maybe a 10-second delay or something like that. Anyway, sometimes I find if I refresh the page, then that helps. Let's see. Come on. Yeah, see there, and yeah, so I refresh the page and then all of a sudden I've got 9 viewers. Imagine that. Anyway, we'll just wait just a minute or 2 just to give people the chance to come in a few minutes late. I hope you guys are doing okay. Let's see here. Good morning. I'm having some crazy technical difficulties right now. I've never seen this problem before. Watch this. Okay, have you ever seen this before? Okay, so I recently made the switch over to Linux. But the thing is, my streaming software uses, my streaming hardware is this thing here, this HD60S by Elgato. A lot of Twitch streamers use this for gaming and everything, and they do not have this available or they do not have the drivers available on Linux. So you're stuck with Windows. So I have to boot into Windows every time I want to live stream, which is quite often. So you might notice here that the time is fixed now. The time is fixed. But what happens is every time I log back into Windows, the time goes all wonky. So what I tried to do today is here, I'll just minimize all this. I right click this and then adjust date and time. Here's my settings. Oh, gone. What? Look at this. Adjust date and time. Closed. So I thought, okay, no problem. I'll just go to my start menu. What? That's not good. Right click it. So I mean, like, the file explorer works. Like I can open, but I mean, all of these sort of system things are just, Windows is completely broken right now. Luckily, Task Manager works. Task Manager works just fine. But yeah, I'm Windows error reporting. How about that? Yeah, so I'm having some pretty strange times in Windows, and it's making me realize how happy I am that Linux exists. Oh yeah, thank you. Yeah, this is actually a Game Boy Zero. It's not your typical Game Boy. Check this out. So it runs Raspberry Pi, and also RetroPie, which is a distribution of Linux that you can run on a Raspberry Pi. And then look, it runs emulators here, and it's pretty sweet actually. So these are the games that I have available for it. It's pretty fun. It's a nice little thing just to have around your living room. It's pretty fun. I really like it. I mean, it's not better than like actually playing like a normal Game Boy, but hey, that's what this is for, right? That's what I mean. This is what an original Game Boy looks like. So they look almost identical. Although this one is substantially heavier. Actually, you know what? If this thing had batteries in it, because this thing takes 4 AA batteries, so it's quite a bit lighter. But when this thing is filled with batteries, it's I guess it's about the same weight. And then this is my little USB charger, so I can take this little thing. It's one of those magnetic ones, so you can just charge it like that. You can see it's charging. But normally it's just a USB-C. This is just a little dongle, and then you can charge it like that. It's pretty sweet, eh? It's a lot of fun to play with. One of my favorite games growing up was this game here, Chip 'n Dale Rescue Rangers. It's a lot of fun. I set up some script to load before the game plays, but I forgot to connect it to the Wi-Fi, so the script needs Wi-Fi, so it's just waiting for an internet connection. It doesn't have it, so it takes a second for games to run, but yeah, it's pretty fun. So it's still saying 9 viewers. I'm going to refresh the page, see how many people we have here, because I'm taking it that we have more than 9 viewers. Oh yeah, we got 18 viewers. Okay, so I'll get started in just a second. Oh, Double Dragon. Hey, oh, hold up, just 1 second. Double Dragon, are you kidding me? Love that game. Here, check this out. So these are my Game Boy games. I know I'm getting a little off topic here, but hey, it's good to have fun every once in a while, right? These are my Game Boy games. So Ninja Turtles, Follow the Foot Clan, classic. I'm pretty much like I don't really like. Oh, here we go. There we go. Chip 'n Dale. Boom, 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 boom. This is a really fun game. I'd highly recommend playing this game if you have access to emulators. It's a super fun game. Come on, I guess you have to. It's hard to play this game one-handed. There we go, and then you can throw these things at the bad guys like this. So check this out. Haha. Yeah, not really a one-handed game. Oh. So yeah, it's really fun. And then you can turn the Game Boy off like that. Yeah, so I've got Follow the Foot Clan. I was saying I don't really like superheroes or anything. I'm not like a big superhero fan. Like I don't really watch those like the Marvel movies, but anything Ninja Turtles, like those are my superheroes that I really love. That's what I grew up in the 90s, sort of worshipping. I just love Ninja Turtles. I guess it's kind of hard to see, but up here I'm not a comic book nerd, but that's my stack of Ninja Turtles comic books. So I'm slightly a comic book nerd, but only when it comes to Ninja Turtles because they're super cool. Super Mario Land, obviously. That's why I went to get this Double Dragon. Great little game. What's this one? Oh, Wave Race. This game was super fun on Nintendo 64 and also GameCube. But then the original was actually Game Boy. And then this one here is Mortal Kombat 2. Super fun, kind of violent game though. And then Kirby's Dream Land. This is a great little game. I thought I had a few more games. Obviously Tetris. This is like you can't have a Game Boy and not have Tetris. And I thought I had a couple other games, but I guess that's it. The thing about these things is they're so small that it's easy to lose these games. So anyway, what do you say we get started now? So that was a fun little way of waiting for people to show up in the stream. But I also think that in this sort of pandemic teaching, it's important to sort of get distracted and have fun and just remember that life is more than just showing up to school, showing up to work, and kind of doing the work of that society tells us to. It's important to have. It's really important to have fun. Like I can't stress that enough. You gotta enjoy your life. You only have one life. Let's enjoy it. I mean, we do have to do our work, and we're going to do our work, but I think that we should have some fun too. Okay. Oh, you have an emulator on your Switch which plays all the NES and SNES. Oh, that's awesome. My favorite console is SNES for sure, hands down, the best console ever. Like there's never been a console that has come close to the SNES. That is, or the SNES as it's sometimes referred to. You have the MK1. Oh, Mortal Kombat 2 and 3 on your Genesis. Oh, nice. Genesis was great as well. I never really had a Genesis when I grew up, but I purchased a Genesis about 5 or 6 years ago, and more like 6 or 7 years ago, and then got acquainted with those games. A lot of the same games as SNES, but not completely. And also, Nintendo, like they were kind of known as being sort of like the family friendly console. So in Mortal Kombat, I think that they either removed the blood or they made the blood green or something weird. They did some kind of weird censorship. But then on Sega Genesis, the blood was red, or just it was blood. There was blood in Mortal Kombat. I'm thinking of. So Sega Genesis was kind of thought of as like the more mature console, but they had major console wars. All the commercials when I was just a little kid, they were all about the Sega Genesis is like way faster, because the thing is Genesis came out before SNES, so they were comparing it to the NES. Anyway, a lot of fun history. I really love those old consoles. I love playing old games. I've got a huge collection of emulators, and also you guys remember in my classroom I have all those old consoles. I love playing old games. They're just so simple. They're so simple but so hard. Like those old games, they are truly hard. Like if you sit down with a current game now, they're long games, right? Like I'm just finishing the game Witcher 3, and I've been playing it for like a couple of years. I've been playing this game for years. But the thing is, it's never really been that hard, right? Like I've never been stuck on a level. It's just you kind of are sort of guided through, and there's tutorials and things like that. But those old games, you got 2 buttons, a D-pad, and that's it. And somehow those games are just so hard. And there's of course there's reasons why those games are hard. It's because they couldn't make the games big. So in order for them to be lasting and so you could have fun with them for more than just a day or two, so they would make them hard so that you would be sort of stuck on the same level. What's Double Dragon? Double Dragon is a what do you call those? It's just like a fighter game. You kind of just like walk around the screen and then punch guys. Like it's kind of like a 2D, but it's sort of 3D, and you just kind of punch them. You can kick them, and then I think the premise of the game is that your girlfriend gets kidnapped by bad guys, and then you have to go save her. So kind of a simple plot. You've been grinding Warzone. Karate, yeah, it's a karate platform. That's a great way of putting it. Just cracked it. Arena Fort. All right, that's Warzone. Is that the new Call of Duty? Mario Bros. Kind of like Mario Bros, except more of an emphasis on fighting. Yeah. Anyway, what do you say we get started? It's been about 16 minutes that I've kind of been rambling. Today I want to talk about functions and relations. So that's what we're going to talk about today. Just a couple things before we actually start the math. I want to point out that I put the rubric for the final project on the website today, or yesterday actually. So you can go check that out. I also heard some news yesterday that there will be no traditional final exams. Witcher is an amazing game. So I heard that there may be no final exams this year, which would mean, if I understand this correctly, that everyone would have to do the project. So I am currently looking into that. I don't want to, say anything for sure, but I do want to let you know as soon as possible that you may not be able to do a final exam if that's what you chose. And I know that this class in particular, there was a lot of people who wanted to do the final exam. So I'm not sure if we're going to be able to do that. We may have to just do the project. Okay, so I just want to let you know that as soon as possible that you may have to do the project. I will find out. I'm hoping that I find out by the end of the day. I sent several emails yesterday and haven't heard back yet. But yeah, that's important information that you may have to do a project instead of a final exam. So with that in mind, let's get started. Okay. Okay, what are we doing today? So you've probably been able to recognize by now, at this point, we've covered our curriculum, our grade 9 advanced curriculum. And what we've been doing the past couple of weeks is just doing a review of the major topics that we've had throughout the year. This topic coming up is on functions and relations. So this is a big one, and this one honestly will probably take us to the end of the year. So this is going to be like it will likely be our last major review topic. Oh yes, have I not told you? I thought that I had already told you. So the last class is June 19th. So June 19th is the last class. So I'll just write that down. Is Friday, June 19th. Okay. So yeah, that is our last class. Our final exam / project. So I'll just write project is due Monday, June 15th. Okay. So those are some important dates that are around the corner. So we've got less than a month of classes. So yeah, we've got this is the home stretch, right? We're almost finished the year. So yeah, so our last class is June 19th. And just to give you an idea of, and this part doesn't concern you, but I think it's important for you to just have an understanding so that you can see why I will not be accepting any late projects, is that report cards are due, like I have to be finished writing my report cards on June 17th. So that's between these two dates. So this last week, there will be very few classes. I will probably have like one class in that week, and it would probably be more of like a celebration kind of a class, and where we kind of just hang out. It'll be after the final project. Something that I will be doing is I'll be providing kind of a summary of the year. And this kind of summary will be something for you to sort of hold on to over the summer, and make sure that it's something that you understand. So going into next year, it's going to be really important that you know what's expected of you. Because this year, the past couple of months, it's been really challenging for teachers to sort of actually teach, right? It's been challenging for everyone. This has been completely unprecedented. So what we've been asked to do is to provide our students with kind of like a summary of the big topics that we need to make sure that you understand these big topics. So that's something that I'll be providing in that last week. Yeah, so will we have you as a teacher next year? I believe so. So the thing is, teachers usually don't know what they will be teaching until like late June. So I don't know for sure, but I'm planning on teaching grade 10 advanced, both sections. So as far as I understand, I think that there will be two classes of grade 10 advanced, of which I'll be teaching both of them. That's the current plan. But the thing is, plans change, and nothing is for sure. So so you can, like, if I had to place money on it, like if I was someone who bets money, I never bet money, by the way. I don't believe in gambling. But if I were to be a gambling person, then I would bet on me teaching it. Yes, but like I say, that's not for sure. But it is likely. It is likely. Okay. So yeah, I think that's enough rambling. Let's do some mathematics. So what we're going to talk about today is relations, and the big part of relations that's important, that I really want us to get a hold of, is different types of notation. So let's talk about what we're going to talk about. So we're going to do we're going to start off with relations. Okay. And you can just let me know in the chat if you're familiar with what relations are. So we're going to talk about relations. I want to talk about the notation that we can use. I want to talk about domain and range. Okay? And I want to talk about graphing. Now, graphing is something that we have experience with. We've got a lot of experience graphing, right? We've been graphing pretty much as like since the first class that I saw you, almost. I think one of the first things we graphed was the sine and cosine and tangent functions. I don't know if you remember that, but we measured all those triangles. I got you to input that stuff in that Google form, and then we got to see those cool graphs. So so yeah, we've been graphing for some time now. So this is what I would like us to cover for today is these three things: notation, domain and range, and graphing. So a relation. So in case you don't remember, a relation is a way of associating two numbers. Okay, or I should say pairs of numbers. Associating pairs of numbers. Okay? So, let's see here. Let's say, okay, so we could say something like this. I'm going to make a little chart here. So this is one way of describing a relation, is to have an input, have an output, and then the relation itself here. Okay, so if our input, I mean, one of the major variables that we use to describe input is x, and the output is pretty much always y, x and y, right? So let's say that the relation is a linear relation. We're familiar with linear relations. So the relationship between x and y would be that y is equal to 2 times x plus 1, right? And we're familiar with this, right? I'm not intending on this being new at all. This is absolutely a review. But the idea is that, like, if the input was like 3, then well, let's see what y would be equal to. So y would be equal to 2 times 3 plus 1, which is, well, 6 plus 1 is 7. So so this relation here would be the ordered pair 3, 7. So this is what we call an ordered pair. It is called an ordered pair because order matters. X comes before Y, or in other words, our input is first and then our output comes second. And then it's a pair because it's two numbers. Okay, so that's what we call an ordered pair, and this relation can happen with any set of numbers. So in this case, our input is any number, and it turns out that our output, we can also have any number as our output. Okay. All right. So that's one way of describing a relation is to give a some kind of mathematical expression. Right. Now another way. So right now I'm thinking of notation. Like how do we write down these relations? So another way of writing a relation is using mapping notation. Okay, so mapping notation is I kind of remember doing this a little bit in school, like when I was in grade 9 or grade 10, or I forget exactly which grade it was when I learned this, but I do have a vague memory of doing this. But then once I got to university, like this notation is the main, well, not the main, but it's huge in university. So having a good understanding of mapping notation now can help you later on if you plan on studying math in university. So mapping notation is where you have two big circles like this. They are not overlapping. This is not a Venn diagram. It's not a Venn diagram. Basically what you would have is you would have your input here and your output here. Okay? And then basically what you would do is you would write all the numbers that you're talking about. In this case, it wouldn't be any number. Your input wouldn't be any number. Your input would only be the numbers in this first green circle. And then you would have your output like this. So you would have maybe this first dot would be like 1. This second dot would be like the number 3. Maybe this one would be -2. Maybe this one would be 2.1. Okay, and then maybe on the right here, maybe this first number is the number 7. Maybe this second one is the number pi. Maybe this one is the variable x. Right? It can be, what I'm trying to say is it can be anything. These can be any numbers. They can be variables. They can be anything. And then what we do is we connect these. So we say that we have a relation between maybe 1 and 7. Maybe 3 and x are associated with each other. Maybe -2 and pi are associated with each other. Maybe there's a relation between 2.1 and 0. Okay, and that's how you would describe a relation using mapping notation. So, some of these ordered pairs. So this ordered pair right here would be the ordered pair 1, 7, right? That would be 1, 7. This one right here would be the ordered pair -2, pi, right? So there you have your input and your output. Now keep in mind that your input might not have a number that's included in the relation. So it's possible that maybe you have the number 9 here, but 9 is not associated with any number in here. Okay, maybe the number 1 is in the output, but there's no number associated with it. Okay, so you don't have to have all of the numbers in your input being included in the relation, and you don't have to have all of the numbers in your output included in your relation. So that's an important point because that has everything to do with our domain and range, which we will talk about shortly. I think that that's the next thing that I want to talk about. Okay, so we've got mapping notation. Another way that we can describe our relation is a list, or sorry, I shouldn't say a list. We can say a set of ordered pairs. Okay, and what I'm going to do, I want to copy this exact relation that I have above to show you that you can describe the same relation using different types of notation. So basically the way we would write this is I would say, okay, well, what are all the relations that I have? And I'm going to write them in a set. So using set notation, right, we use these nice curly brackets. So the first one that I see is 1, 7. So I've got 1, 7. Then I write a comma. And then the next one that I see here is this one here, 3x. So I'll write that, 3x. And the one after that I see is negative 2 pi. So I'll write that one down. I've got negative 2 pi. And the next one that I see is 2.1 and 0. 2.1 and 0. And then that's it. Those are all of my relations. Okay, those are all of my relations. So that's how you would describe this relation using a set of ordered pairs. So I just want to be clear here. So these symbols right here, these tell us that this is a set. Now here's the thing about a set. With a set, order does not matter. So order doesn't matter here. Okay, so what I mean by that is I could have this guy come before this guy, and it doesn't matter. In a set, all that matters about a set is if one of the guys is in the set or not in the set. It doesn't matter which order they come in. So using a set notation, you don't have to be concerned about what the order is. That said, each of these guys here, this is an ordered pair. Here, order does matter. So although it doesn't matter which of the ordered pairs comes before what, like we can switch these around at our heart's content, and it doesn't matter. Oops, I should bring that with it. It doesn't matter, like we can kind of switch these things around, but inside here I can't switch this. My input has to be my input and my output has to be my output. What I did just there is not allowed. We cannot switch the order of our ordered pairs. Okay? So the input does have to come before the output. Okay? But the order in which the ordered pairs come doesn't matter. Okay, so that's one way of doing it. So yeah, we've done like a table here. So we've done a table. We've done the mapping notation. We've done a set of ordered pairs, and then the last way that we can describe a relation is with graphing. Okay, so with graphing, I think that we're already familiar with graphing, but typically, well, not typically, pretty much always, the horizontal axis, the horizontal axis is represented by the variable x, which is our input, and the vertical axis, I keep saying axis. The vertical axis is represented by the variable y, which represents our output. Now, just keep in mind that these are variables, and they're subject to change, right? So sometimes our horizontal axis is represented by like the letter t, which stands for time. So often we'll see time being the input right? Because that makes sense to think about how something changes over time, right? That's one of the most common types of graphs, is to show how things change over time. I mean, just look at any government website right now with COVID, and pretty much all the horizontal axes are time. By the way, singular, axis, plural, axes. That's how you pronounce it. Axes. So singular is axis, plural is axes. Okay, so with graphing, we would just have an input and an output, and basically what we would do is just say, okay, well, this would be the ordered pair. Well, in this case, 1, 2, 3, 1. So in our relation, 3 would be related to 1. Or maybe we would have this point here, which would say that, okay, well, this is -2. So we've got -2, -1, etc. A couple things about graphing, just really quick. And I know that we're already really good at graphing, but there's a few terms that I would like to point out. So this is referred to as the coordinate plane. Or the Cartesian plane. And this is named after Gr9 Descartes. Okay, I think I've got a whole bunch of his books right here. Yeah, so Gr9 Descartes is a famous philosopher / mathematician. I think I've got some more of his stuff too. Yeah, here's another. Oh, but this is like the same book. Yeah, I used to be really into Descartes when I was a university student. Really smart fellow. I think I have some of his math books too, but I don't see them right now. Yeah, I'm sure I've got some of his math books. But he was primarily a philosopher. And his big philosophy, his contribution to philosophy was really interesting, and his main question that he was tried to get to the bottom of was, like, how do we know this is real? Like how do I know that my fingers and everything in front of me is real, and we're not just imagining it? And how do I know that I'm not alone in the universe? How do I know that someone else, another human being, is like me, and has a conscience? And how do I know that they're not just a robot? And how do I know that this isn't just an illusion? Really cool stuff, like really interesting. And he actually proves that this is real, and that's how cool philosophy is. So I highly recommend, if you like these kinds of questions and you like thinking about how you can know something, like how does knowledge work, take a philosophy class in university when you're if you have the opportunity to go to university. I know that we don't all have the opportunity to go, but if you do go to university, I can't begin to tell you how much philosophy helped me think, and it helped me think about thinking. So I would highly recommend that. I have so my first degree at the University of Winnipeg was my major was mathematics, and my minor is philosophy. So I took a lot of philosophy courses. And Gr9 Descartes is an incredible philosopher. Really fascinating stuff. So anyway, the coordinate plane is named after him. So we call it the Cartesian plane, because apparently when he was a young child, he saw a spider on his ceiling, and he he thought that he'd be able to determine the exact position of the spider by thinking about how far it is from one corner, like thinking left and right, and then how far it is from the other corner, from the same corner, going up and down. And that's exactly what the Cartesian plane is. So and he also made major contributions to mathematics by bridging the gap between geometry and algebra. So geometry was how we used to always do mathematics. So the ancient Greeks, like Euclid and Archimedes and all those big guys, they did everything in geometry. So there was huge amounts of work done in geometry. And then in the medieval times, a lot of Arabic mathematicians basically invented algebra, and it became very clear to everyone around the world that algebra was actually the better way to think about mathematics, that it's a much more powerful tool. But what René Descartes did is he made major contributions converting all of this knowledge that we have about geometry and sort of translating it into algebra. So major mathematician. So there's my little history lesson of the day. So we've got the coordinate plane. So we've got, our x and y variables that are usually the letters that we use, and not always, like I said. One important thing about it is we have quadrants. So it's split up into 4, right? You can see we've got 4 areas, 1, 2, 3, 4. And we call this quadrant the first quadrant. This is the second quadrant. This is the third quadrant. And this is the fourth quadrant. And that's the order that we have. So you can kind of think of it as like this one is positive, right? Because both x and y are positive. Here, x is positive, but y is, x is negative, y is positive. Here they're both negative, and here x is positive, but y is negative. So that's kind of how we split up that Cartesian plane. Okay, so we've done a table of values, we've done ordered pairs, we've done a mapping notation, and we've got graphs. And I think that's pretty much it. I want to talk a little bit about domain and range very quickly. That way you guys can do the homework that I've got set up for you. Let me just refresh this page really quick. Okay. Okay, so domain and range. Okay, so domain and range. So this refers to so the domain. This is all numbers used in output, and the range is all numbers used in, oh sorry, I got that backwards, input. I don't know why I said output. In the output. Okay, so and I just want to tell you right now, we actually, this word here, there's a bit of a disconnect. In sort of like the high school mathematics world, we call this the range, but in university, we call this the codomain. And the range refers to something a little bit different. There's a difference between codomain and range. I'm going to ignore that for now. We're just going to call it range. But just know that the technical term for what we're actually talking about is called the codomain. Okay? The range is, well, the range is less important than you would think. Okay? I'm starting to think that Yeah, you know, we're almost done here. We're almost done. I'm gonna go over maybe by about 5 minutes, but hey, we talked about Game Boy for like 15 minutes when we first started. So I'll go over just a little bit. So yeah, the domain refers to all the numbers used in the input, and the range refers to all numbers used in the output. And that's all of them. Like we're not skipping any. Okay, so sometimes that could be just a few numbers. Sometimes it's all of the real numbers, etc. So, okay, I'm gonna just do a couple examples. So, e.g., I want to find the domain. I'm gonna write though D and R. Right, just to save time because I want to get through this. So let's say we've got a graph that looks like this. So this is going to be part A, and maybe I've got some kind of, so this is a shape that we'll learn all about next year. It's called a parabola. Okay, and so that's our first one. Our next one here would be this. Okay, and what I'll do is I'll say that this is the point 2 here, and then this would be our relation. Okay, so all the points on here are the relation, and then I'll also say that this is the point 1, 2 over here, and then there we go. Okay, so so there's 2, and then how about another one like this? So let's say that I've got this point, this point, this point, this point, and this point. Okay, so those are the points on my relation, and let's do this one here. And then, yeah, I think that's good. Okay, so that was A, B, and C. Okay, so this one here, let's talk about the domain and the range. Okay. So the domain is all of the numbers that I have in my input. And remember, my input refers to this x-axis, right? So just looking at this graph, and the way that it works is that I've got this kind of sort of like parabola shape. It looks like a U. And basically what's happening here is that this shape keeps on going to the right. Like it's going up as well, but it's going up and to the right. So there is no limit to how far to the right it goes. And same with the left. So the domain is a set of real numbers. Okay, so any real number can be used as the domain. The range, well, let's think about the range. So the range is all of my output, right? And we said that the output is our up and down values, right? So it doesn't look like there's anything going on down here, right? So the range is going to be all numbers that are bigger than or equal to 0, because it actually is touching this point 0, 0. So the range is all the points bigger than 0. So this is what we would call interval notation. Okay, and interval notation is used to describe a range of values. So if you don't like using this notation, and I'll talk more about how to use this notation in subsequent classes, but what you could also say is you could say that it's all values y that are greater than or equal to 0. This is how you could write it as well. Okay. Okay, so that's the domain and range for the first one. Let's do the next one here. So for part B, so it looks like, and I should actually include these little dots here. Okay, and this should be green. So we've got a circle here. The center of the circle is this point 0, 1, right? Oops. Right, so here's the center of the circle. We've got a radius, it looks like, of 2. So it's kind of going around like so. Each of these radius is going to be of length 2. So the domain is pretty much all of the x values, like our input values, that are used here. So we're going to start off with this one, and we've got all of these values that are used, and then it ends there. We have no values over here. We have no values over here. So the only values in our domain are between -2 and +2. So what I'll write is that our domain goes from -2, which is less than or equal to x, which is less than or equal to +2. And that's how we would write the domain there, is that x is any value between -2 and +2. Now for the range, it's very similar, right? So our output, that's like all of our y values that are used. So it looks like I can get 0 here, and any value between 0 and 2 is used. So here I would say, and I guess technically now I've gone ahead and made this more of an oval than a radius. Actually, come to think of it, this is not a radius, or sorry, this is not a circle. This is an ellipse. But in any case, the range is, well, the smallest value that we can have is 0, and that's less than or equal to y, which is less than or equal to 2. Okay, so that would be the domain and the range for those two values. And then finally, let's take a look at this one. And I know usually I like to have you try these questions yourself, but we're running out of time here, so I want to make sure that I show you how to do this before I assign some homework. So let's take a look at all of these values. So you'll notice that these values are not connected, right? What we call these, we would call this discrete. Whereas something like this we would call continuous. Okay, so this is continuous because you can like draw it with a pencil and never take your pencil off the page, where these discrete values, it's just a single point and a single point. Okay, so with these discrete values, what I'm going to do is I'm going to say, okay, well, which values do I have in my input, right? So which values do I have in my x-axis? Well, I've got this value, like -1. I've got 0. I've got 1, 2, and 3. So the domain would be -1. And I'll put this in set notation. So I've got -1. I've got 0. I've got 1, 2, and 3. That's my domain, because those are all the values that I used in the x direction, right? So I've got this one, I've got this one, I've got this one, I've got this one, I've got that one, and then this one I've used twice, right? It's important to know I use this one twice, but I only have to write it once in the domain. So the domain doesn't tell you how many times you used a value, it just tells you whether or not you used the value, right? The range, on the other hand, the range is going to be, well, now we're looking at our y-axis, so which values of y did we use? Well, we use this one, this one, this one, this one, and this one, right? We use this one twice, but we don't have to write it down twice. We only write it down once. So this would give us -2, -1, 0, 1, and 2. Okay? And yeah, so that's how you do domain and range. So I know that we went rather quickly. I'll do some more examples on this stuff tomorrow, but I did want to just make sure that you had some idea of domain and range before I assigned a bunch of homework for you. So I'm going to put some homework on the website. I'll also put it on Google Classroom. That way you get a little notification. Oops, that's not what I wanted to do. And then yeah, that's what yeah, I guess class is done. So yeah, I guess for the exit slip today, exit slip, just say hi. Say hi, and then maybe, what's your favorite video game? Because we were talking about video games today. So tell me what your favorite video game is. Say hi. Tell me how you're doing. I'll just keep it simple. Remember the exit slip, I'm really just doing this for attendance. And keep your eye out for the homework. It'll be up in, I don't know, maybe by lunchtime. It'll be up by lunchtime. Okay, take care, guys. Have a good day. Bye-bye.